Good day, folks. It's Tony from the tech firm. I want to show you how to do something that everybody has built into their Microsoft operating system. It's Microsoft's Pktmon, their packet analyzer. You can capture packets natively in Windows 10 and higher. So I want to show you how to capture CDP packets, find out what switch, port, and all that kind of stuff without installing any third-party protocol analyzers. Enjoy, folks. You have to make sure that your command prompt is elevated privileges or run as administrator or whatever you understand that to be. And you know for a fact that works when you see here it says administrator command prompt, then you're pretty well in business. Down here, the path, the default path for most systems will be Windows System 32. If you're in a corporate environment, you could have changed that, and I'm not going to get into that, but just so you know, you need an administrator command prompt or elevated privileges or however you want to call that. So just a quick reference for everybody, because I always like to give credit where credit is due. This all started because I always read this website called bleepingcomputer.com, and they came out with an article saying Windows 10 quietly got a built-in network sniffer and how to use it. And that kind of got my attention, but I noticed it was kind of limited to what I'm used to. And then again, I'm used to using the netsh trace command and or of course Wireshark and other types of protocol analyzers. So I kind of just ignored it, but now with this latest one, they updated the article, and guess what? It really got my attention. So I thought I'd play with it, show you a kind of quick start on how to get going. Some of the things I'm going to show you are echoed in the article, and some are not included in the article. So I thought, why not? Let's just run through it real quick. So here we are at the command prompt. For the people who are not familiar with their command prompt, a lot of people aren't comfortable with it. I want to just show you how to move around a little bit. For example, I want to change directory, so that's CD. And I'm going to go to my desktop. So user profile is a variable set. Whoops, profile, if I can type. User profile. And then I'm just simply going to do a \desktop, enter. Now I'm at my desktop. So this saves me the trouble of having to, CD, user, CD, home, CD, desktop, that kind of thing, and that takes me right there. I also want to create a folder called Pktmon, so MD for make directory, and Pktmon, let's just type that in. Oh my god, it's gonna be one of those days, folks. So there we are. So I've made the directory. Now I'm going to change directory, Pktmon. There we go. Now I'm in the folder, so everything I do as far as packet captures and whatnot goes is going to go into that folder, and that's very helpful because I don't want to have to go hunting for it, and I sure as heck don't want it in my System 32 folder for just a whole variety of reasons I'm not going to get into. So now that I'm in there, the first thing we do with any protocol analyzers is interrogate our adapters, and even with Wireshark, when I did a T-Shark or the dump cap things, I'm always checking out my adapters first. So Pktmon, I'm just going to type that in just for a moment. It shows me kind of a help screen, if you will. The help screens are pretty good. I always wish there was more detail, but just for the purposes of what it does, it works fairly well. So Pktmon, COMP, and then from there we're going to type list, enter, and it shows me the adapter. Now this adapter is my active adapter that's being used. If you don't see it or you want an idea of all the adapters you could capture from, a -I will take care of that. So I'm going to press enter on that, and you'll see there's a lot more stuff on that screen. I'm just going to drag this guy here for a moment, and I'm just going to stretch this out just so you got more real estate to read. There we go. And the reason why I do that is because sometimes the adapter you're using is not active right now, like a VPN adapter, that sort of thing, and you just want to note this, the ID number. So ID in this case was 2, and that's if I wanted to use this WAN mini port adapter. But if I just go back to my list, there's my gigabit Ethernet adapter, there's my MAC address, it gives me the ID number. In this case it's 9. It's going to be important in just a moment, so just remember that. Of course, it tells me a bunch of other stuff, which it doesn't really matter right now for the purposes of this video. Now, the next thing is we want to start a capture. So the first thing we have to understand is the defaults. And the defaults when you do a packet capture is all adapters, and you might not want that. If you did have more than one adapter, Wi-Fi, 2 Ethernet, or there was multiple adapters being used at that time, you'd want to pick one, and that's the -C parameter. And I'm going to put all these parameters in the write-up, so don't worry about trying to write this stuff down. But for the purposes of what we're doing, I want to just capture from all adapters. So I'm going to do a Pktmon start double dash. It's one of the few ones where there's a double dash there. ETW. A few things about the defaults. Packet size. The default's 128 bytes. I want to prove or disprove if that is the case. You know me, I'm always checking that stuff out. So I'm leaving that alone. The file name, the default is Pktmon.etl, and that I'm going to leave alone as well. And the maximum file size, the default's 512 megabytes for the file size. That I want to change. I want to see if that works. So -S for size, and I'm going to pick 2. All right. That's it. That's it. So real simple. Enter. Boom. And you can see it says that it started. That's where it's putting the file. The default name is Pktmon.etl. The logging mode is circular, which all that means is first in, first out. And the size is 2 meg. So when this is done, and this PC is a pretty busy computer, so I know for sure that by now 2 meg should be done. You'll know when it's done when you do one of two things. So this is where the fun starts. I'm going to open up my File Explorer. Here we go. And whoops, I just shoved my whole screen off to the side. Didn't want to do that. So from here you can see there's my ETL file being created, and it's 16 meg right now, not 2, even though this did say 2. So let's stop the capture. Pktmon stop. Okay, so it's done, right? And no events are lost. That's good to see. And if I come back here, it's 32 meg, not 2. 32. I don't like that. I'm gonna have to look into that, but for now I don't like that. So the other thing we're going to do is convert this to a PCAP format, and that's what Wireshark or other protocol analyzers like to use as well. So we'll quickly do that. And so now that it's done, if we just type dir, we'll see. There you go. It is 33 meg, that ETL file. So we would like to convert that. So we're going to Pktmon, just hit enter again, just as you get used to it, just get familiar with what commands are available. And from there you'll notice that one of the options is pkapng. This is the newer option. The previous version did not have this in it, so you might not see it if your Windows updates aren't up to date. So again, Pktmon. This time we're going to type pkap ng. This time I'm going to type the word help just to show you what it looks like, and you can see it tells me Pktmon pkapng log.etl and then -o and whatever. So input output file, pretty straightforward stuff. So I'm going to simply type Pktmon.etl and then -o. I'll do the same thing, why not? .pkapng. Enter. Bing, bada boom. Processing. And what I want to see is when it's done, is it still 2 meg? I mean 33 meg and change, or is it magically 2 meg, which I kind of doubt, but we'll see. And you can see now the pkapng file is 9.2 meg. So that 2 meg size thing, I don't know if that's a bug or there's some other thing you should do, but I would doubt that. I think that may be a bug. So now I'm going to type Pktmon pkapng. That's going to launch Wireshark. There we go. So let me just drag that over here. And that should just load. There we go. The reason why I want to load that in Wireshark is obviously I want to make sure it works. So it did work. The other thing I want to check is that packet length, because I told you the packet size by default is 128 bytes. And sometimes you want the full size packet, sometimes you want 128. But in this case, if I pick a, there you go, this one is 1514. If you take a look at the header here, it says 1514 on the wire, 128 bytes captured. So there you go. So that default does in fact work. So I want to possibly do more articles, but I'm going to ask you if you think it's good and helpful, then I will proceed with more articles and more options, features, and I'll test them out for you, make sure stuff works, and that kind of jazz. So leave your comments, and I look forward to hearing back from you. Have a good day. Bye for now.